Hello, everyone, and welcome to today's Cloudinary Cafe webinar. My name is Alexander, and today we'll be going over the topic of manual to automated, achieving copyright compliance of model images with Cloudinary. So what are we focusing on in this session? Let's say you are a fashion retailer and you're handling tens or hundreds or thousands of images, model images for your products, and you're also sharing them with concession partners or any other retailers or marketplaces. Oftentimes, they would have their own requirements on how those images should look. That can range from the particular background that the images have, or perhaps the dimensions of them, the formats. It could be that model images, they should be cut from a certain facial landmark down so that they're not recognizable. These are some of the common brand guidelines and requirements that we see in this industries. So if you are such a retailer at the moment, you might have a team that works on generating these images to meet the guidelines of the partners that you'll be sharing them with. That can involve editing them in software tools like Photoshop to change backgrounds or crop the images as and when required. And while that process, depending on the case, of course, can be relatively quick, if we're talking about a large number of images, hundreds, thousands, depending on how many products you have in that collection and how many you need to share, it can add up to a significant amount of time. So what we want to see here in this session is how we can automate this process through the use of various features on Cloudinary to hopefully speed things up and make the team more efficient in their work. But again, achieving the same quality and results that they did before. So let's break down the problem that we'll be covering today, and then we'll see what features on Cloudinary can help us achieve it. So today we'll focus on a particular topic of cropping model faces for compliance or expiration purposes before sharing them with partners. So let's say you have model images and you have a license to use them for, let's say, a year or another time frame, or just the partner you're sharing them with just requires them to be cropped so that the model's face is not visible up to a certain facial landmark, let's say the mouth or the eyes or the nose, and you need to crop those. So at the moment, a user would pull that image up in Photoshop or another tool, crop the image, save it, and move on to the next one, which is not a slow process and is very easy for a user to do. But we'll see how we can automate that. And for us to start this process of automating it, we need to think about the detection of the facial landmark that we need to crop at. So for us as a human, we know exactly where it is and we can crop it. But for something automated, we need to figure out how to do that. One way we can do it is with the content analysis add-on that Cloudinary provides. So we'll be using that one as part of our demo later on. That one would give us information on the different landmarks it finds on the face that we upload from the model images, and we can use that later on as part of the transformations to perform the cropping. Once we get back the results of the add-on, we can use a non-success script, which is another separate feature on Cloudinary, to process the response and store information that we're interested in, specifically the coordinates of where that landmark is, so we can use them later. We're going to be storing this information in contextual metadata on Cloudinary, which is a key value store of data that we can attach to an asset, and we can reference that within our transformations. We'll be using variables to extract the data from the contextual metadata and then use conditional transformations to decide if there is data there, then we want to perform the crop based on it. So we'll cover conditional transformations feature as well. Cropping the images, this is bread and butter of Cloudinary, so all of the transformations options that we have on different cropping modes, so we'll cover a couple of them in this session. We'll look at how the transformation URL looks like with the above logic and how we can simplify it with the use of named transformations and templates. We'll also review how we can go over all of the automated crops and review them before publishing. That's also important. So any solution we think about, we need to make sure that there are ways that the user can intervene in different steps and make it easier for them to correct anything that is not right. And lastly, we'll see how we can use collections to share all of these images with the transformations automatically with external partners and vendors. So I've logged into my Cloudinary account here, training demo, and I have a bunch of images of model images that I will upload. But before that, we want to create what we call an upload preset, which is a way of us bundling some upload parameters together, and we can apply them to each of the uploads that we do. And the upload preset will hold some configuration that tells us to use a particular model as part of the content analysis add-on. So if you haven't enabled that in your account and you want to try later on, you'll see a button here that will get you to the add-on marketplace, and all of the add-ons have a free tier which you can subscribe to test them out. So I've already subscribed to the add-on, but I'm going to open the code here just to go over the upload preset that we'll be creating. So I'm going to call it model images. There are some options that we are going to set, including how the public ID is structured and details about whether folders should be there. But what we're most interested in here as part of this session is the detection, which denotes the model that we're going to run for the add-on. And also we have the onSuccess script that we have, which is a bunch of JavaScript. Here is minified, so I'll switch to a new tab in a second that will have a much easier to read version. But let's first create it. So I'm going to run that. Cool. So we have model images created, and we can verify this by going to the settings. And I've just refreshed, but it already did so just as I opened it. We have our model images upload preset with the code that we just set. Now, before we use that in the UI, I'm going to upload one of the images programmatically just to show you the response that you get back from the add-on and what we'll be working with behind the scenes. So it's a bit clearer. So I'm going to take this first image and I'm going to upload it to, actually, let me zoom in case it's not visible. There we go. So I'm going to use the Cloudinary CLI here to upload that image that I just copied. And then I'm going to pass in detection and then new. So the model. And yeah, for now, let's actually set the public ID of test model image, just because I'll upload the rest through the upload preset, which adds some additional automation, but I just want to show you the response at the moment. So I've just uploaded that image. We can see it in my account over here, and let's look at the response. So if you've already worked with the API, this response will be familiar to you. A lot of information on the asset, including the dimensions, but what we're interested in here is the section under the info object, which shows us information from the output of the add-on. So it has the model name, which we know, but under the tags, we have different facial landmarks, and not only because it's human anatomy, but for this example, we'll focus on the face, and where it identified them. So it has the top left and right, so X and Y coordinate of the top left point, and then a width and a height of how wide that bounding box is. So we can locate it on the image. It also has a confidence score, so how confident the add-on was that what it found is indeed there. And we have some of the ones that we're looking for. So we have eyes, we have two of them in this case, so we have an array. We have hands, other ones. So this is the information that we get back from the add-on. And the reason I wanted to show you here how the response looks like is because it will tie into the code that we have as part of the onSuccess, which runs against this output, but automatically in the background now that we've set it in the upload preset. So what the code does is basically go over this response that we just saw and extract, in this example, two parts. So the bounding box for the mouth and the eyes. So we'll extract those and we're going to store it as part of the contextual metadata. So this is handy so that we don't have to perform a secondary API call on our side or use webhooks and make a more complicated workflow. We can just run onSuccess and extract the values we need. So let's actually see that in action. I'm going to upload all of the images again, but in the UI. So I'll just drag them here. I'm going to select the upload preset, which is model images that we created earlier. All right, that looks good. All right, we have all our images here uploaded. And then you see as part of the contextual metadata, we have a couple of keys. So eye and mouth, and we have some coordinates. So this came from the response of the add-on that we saw in the command line. But for each image individually, it extracted the relevant coordinates that we have. So all of them have it. And some of the images are like, I picked some random ones, like this one faces backwards with slight visibility. So I try to select ones that are varied, so you can see that it does a good job of detecting those. So now that we have those uploaded and we have some information on where the landmarks that we're interested in are, how can we actually transform the images so that it crops them? So I'll just start with one of them just to show you how that looks in the URL, and then we'll see how we can bulk preview them as well within Cloudinary. So this is the image we have of the original image that we uploaded. I'm going to take the transformation here that we'll apply, and I'll just go over it before we use it. So here with the $ and my, this is just a variable that I'm defining. So this is the syntax. I'm extracting data from the contextual metadata. So we are prefixing the next section with CTX for context. The next section here explain or determines which field of the contextual metadata we're interested in. In this case is the mouth. So we saw that we have that on all of our images. So it's accessing this variable at the moment. With this, I can ensure that it's an integer just to make sure that it's cast to the right type. And then I can use conditional transformations. So in our example, all of the images have this coordinate, but in case they don't, we can choose to apply a different transformation. So here I'm using conditionals. So we have an if statement is defined. So this is the keyword that we're using here. And if our variable is defined, in other words, if we do have value for that contextual metadata field, we want to use the cropping mode of fill. So we'll crop part of the image. We have height. So this is it's an intrinsic variable that Cloudinary provides that holds the height of the image. And I'm going to assign it the value of itself, and we're going to subtract the coordinates. So effectively, we're taking how far down the landmark that we're interested in is, and we're going to crop the image up to there and focus on everything down. So the gravity parameter tells us to shift the focus down, which will effectively crop the top part. The width will stay the same, so I'm just setting the width to itself, and then I'm closing the if statement. So if we copy that, we can go in here and just add it to the URL. And so that will crop it for us to the top part of the mouth where it detected. So that was the code that we have in onSuccess. So here we're taking the top part of the mouth. So we can do this for other images. We can just replace, for example, the public ID, which is the identifier of the image. We can replace that part at the end with another image of ours, and that'll crop it as well, which is good. So now we have that output, but how can we preview this in bulk? Because this is very slow and we have to edit the URL. So let's see how we can do that. If you go under the transformations tab, we can access the transformation builder. So we can open that up. We can select a bunch of our assets. So I'll add them. And then under the template section, what I did earlier is created a template to crop at the mouth, which is effectively the same transformation we had in the URL, but we gave it a name so that we can use it in the URL like this, and all of the transformations are hidden behind it. So if I do a quick edit, you will see that this is the same transformation I had in the URL. I just went ahead and created a name transformation for it, and then I can apply as a template. So we can click this button here and see all of our images as the original, how I upload them. And then with just a click, we can transform them and bulk review all of them in a way that's a bit easier and more scalable. So we can see how they're cropping on every one of them. And we can easily spot if anyone doesn't look as expected, but these ones look good. What can we do now with this template that we have, now that we want to share the images after they look good? So we can create what we call a collection, which is a wrapper or a container of assets that we can then share externally with our users. Because at the moment, I need a user to log into Cloudinary and access those, or I would need to share with them a URL with the transformation so that they see the right version. But we can go ahead and create a collection. So I'll create a collection, say model images. We can add our assets to the collection. We have them here. We can create a public link for the collection. We can go into the to the settings and see what we have here. So if you access the link at the moment, you will see all of the assets in the collection, and you have an option to download the originals. But we don't really want to download the originals. We want to allow the user to download a version of the images that are going to be cropped. So we can tick this option to prevent downloading the original, and we can reuse the template we created earlier to expose that and allow the user to download using those transformations. So if we save that, now if we refresh, we'll still see the original images in our collection, but when we click download, it will say that, okay, you can't download the original, but you can download the ones with the template. So that one is going to download locally. So the first time you download this, it's going to transform all of the assets. So it is why it's taking a while. But afterwards, it's going to be very fast to download. I'll go ahead and open that. And we can see that in the zip file, we have the same assets that we just downloaded and the same ones we saw in the transformation builder, but cropped. Now let's say that we want to cover some edge cases. So let's say the detection didn't find a landmark that we're interested in. For example, on one of the images, it might be missing the mouth here. So as we mentioned earlier, we want to make sure that we don't want the user to have to go through a really complicated process to fix any errors. So in case the detection didn't find anything, what the user can do is open this image in Photoshop or any other tool and basically use a ruler or any other feature on that tool to basically drag up to that facial landmark and record the number of pixels up to that point and enter it manually in here. Because the subsequent parts of the transformations, they're relying on this value, but they're not really interested in where it came from. So it could have came from the add-on we just used, or you could in future replace this add-on with a different one. But as long as it gives you the same data, this is what the next part of the workflow relies on. So it allows us to fix things in case of any issues, like missing landmarks. So we can do that. And also, it's very easy to add more landmarks as well. So from the beginning, we were extracting the eye, but in case you want to crop at a different facial landmark, we just want to make sure that the response that we get back from the add-on has this landmark. We can modify the on-success code to make sure to look for it and extract it, and we'll be good to go. Because, for example, now if we go to the transformations, we can go ahead and find our transformation that we used earlier. We can copy it. And since we already have I as part of the contextual metadata, what I can do is I can edit this one and just replace this with I, apply. I can save that as a new template or name transformation, crop at the eyes. There we go. Save that. So now we have two. I can select this name transformation and expose it as a template, and then we'll be able to use it within collections like we saw. But also, if you find any one of the images, if you open that one, you will see your original image and also a preview of the templates that we have available. So the crop at the eyes one we just created will show up here. So now it crops further up to the bottom of the eye. So if we find another image, for example, like this one, we can open that up. And that one would be cropped just below the eyes as well. So it's very easy for us to change that in the future in case we need to. We don't have to process all of the images again. We can just do that. And then in our collection, if we are sharing the images this way, we would go in and either also allow this option or remove the other one in case the new requirements, forces us to use a different cropping. So we can just refresh that and we'll have now another option to download as well. So this one we can remove if needed. So how was the situation before and after? So before there were no automations. It wasn't a complicated process, but it could take significant amount of time for a large number of assets. Obviously, this is going to be time that the team spends performing these processes. And if requirements change, the images would have to be reprocessed again, which is not ideal. Afterwards, we have an automation in place that can perform the detection and extract the relevant landmarks that we're looking for. It's important to always have a way to review them and intervene manually in case it's needed. And we can do that by manually entering the coordinates or bulk reviewing the assets in the transformation builder. This frees up more time for the users who are working on these processes to focus on other media operations. And as we saw, it's quite easy to adjust this to extract a different landmark or expose all of the images with the transformations to our partners. So it speeds up the process of getting the images and sharing them with your users. Now, we covered this use case using a number of different features on Cloudinary, and the idea was that you can combine these features in different ways to achieve your use case. It might not be exactly as the one we went through now, but you can certainly combine features like on success, variables, and other features we covered to achieve your use case. So that was the idea, to cover a wide range of features and put them together to achieve a specific result. In each part of the documentation, there'll be examples and information on the features, how you can use them with the various SDKs, if it's an API or in the media library as well. And in case you run into any questions or encounter any issues, feel free to contact our support team. So they are available. They'll be happy to assist with any questions you have. And you can do so via the support center at support.cloudinary.com or via support@cloudinary.com email address. Reach out to us in case of any questions or issues, and see you at the next session.